now I will start from basic level, actually that is VLSI overview. Now using some software, front end software, like there are a lot of software in market, but educational wise most of the people prefer this Xilinx software, because it provides a lot of flexibility to the user. Another software is Ultra, that is for most complex design, that will be like most accurate. So, most of the designer even prefer Ultra as well as Xilinx. So, we can't compare these two tool are like best. We will start from a basic example like full adder, like this one is the diagram for your full adder. You need 2 XOR gate, 2 AND gate, and I have created this schematic using DSCS3. This is a like module digital schematic 3.1, a part of actually microwave, but you can simulate this one, like see this, when my all input are 1, I am getting sum as 1, carry as 1, and now you can change the input, like see this, I am getting carry, now sum equal to 1. So, you can check out all the test cases, and even you can examine the timing diagram, like these 3 are input and this is carry and sum. So, this is like functional behavior. Now, we come to this front end part. We have to, like suppose this is the specification given by the customer, like you just write code for a full adder. So, simply how we will write the code using HDL language. We will prefer that HDL language. There are like basically we use 2 type of language like VHDL and Verilog. So, let us start from VHDL, actually that is very popular for in educational world. So, just file and new project, click this one. I will take that step by step, like first I will write some project name full whatever, okay, and I will give the path, like this one I have created one folder where I want to save all the file. Actually there will be lot of supported file self generated by this tool. So, I have given one folder name, this is the path I have saved here at present, this one. After that there are options like what you want, like SDL, you want to write the SDL code, or you are going for schematic EDI format or NGC. I will tell this one later on. I will click this SDL, then just click next. After that we have to select the technology file, like in which technology we what is my target technology. Suppose I want to prefer this Spartan 2, and here this is the device name XC2S200, this is from Xilinx family actually, and this will be the number of pin for Spartan 2, okay, and this is the speed grade. After selecting this option, we will go for like what kind of synthesis tool you want. I have already discussed that what is synthesis. Synthesis means convert that high level module into low level gate level module. So, what you want? Xilinx given facility to integrate other tools like model sim, you can integrate these kind of simulators, model sim or simplicity and lot of. So, I will prefer this one model sim, okay, and synthesis tool I will use this Xilinx itself, and in this VHDL. After this formality I will just click next, finish. So, after like selecting these option, I will create one project. After that just right click on this, click on new source, you can write down even After that I will select the VHDL module. After that I will give the entity name. I will tell you later on what is entity actually. Suppose I want to give that name FA, full adder, and this location is same. Then next, here I will define the input output port A like input, B second input, C third input like C in you can say, then sum carry, and this will be my output port and this will be output port. You can define the depth also MSB LSB. After that even you can change this one later on. ऐसा नहीं कि आपने एक बार select कर दिया तो you can't change that one, वहाँ पर भी कर सकते हैं. Even you can change the technology also. Just go to the property. अगर आप Spartan 2 में नहीं करना चाह रहे हो, Vertex सीरीज में जा रहे हो या CPLD में जा रहे हो, just select the property. So there is lot of flexibility. After that finish. So it will automatically create one your folder full adder behavioral. The best thing about Xilinx is that it will automatically generate this code. You all are familiar with this, what is this library, entity, architecture? No. So, I will start from basic, that before any kind of writing to any logic, we have to declare these library which we are using IEEE. After that some packages, these are the packages which will give the internal detail of all the component, basic component which you will use in your design. Okay. So, after adding the library and packages, there are a lot of packages. The standard one, this is important, you have to add this one. These are like if you want arithmetic kind of component, so you have to add this package. After that it has already automatically generated this entity. Entity name is full adder. Entity is like just top level module. It is for like input and output ports. So see this in the format is like that. Write the entity. This will be in like blue color. This is actually the keyword. Like similarly in C language. After that you have written some name of the entity. After that entity full adder is then port. These are the port you have mentioned already. And you can add even more one, like suppose you want to add, then enter add here whatever you want. After that end of full adder. So, this is entity block. After that we will go switch to architecture block. Here there are different kind of modeling like behavioral type of modeling, data flow, I will explain that one also, and like structural modeling. And another is like your lower level module we call, that is switch level module, but that is basically possible in Verilog language. So, not to better discuss here. I will write the code of full adder in data flow, because that is simple expression, logical expression. So, this is the way to write the architecture block. Architecture, this is the keyword. After the name of the architecture behavioral. Suppose I want to write this of full adder. Full adder is your entity name. So, ये automatically इसने कर दिया, मुझे कुछ करने की ज़रूरत नहीं पड़ी. एंड जो अल्ट्रा है, अल्ट्रा में ये है कि आपको स्टार्टिंग से एवरीथिंग यू हैव टू राइट फ्रॉम इनिशियल. बट यहाँ पर क्या होता है, एंटिटी एंड ऑटोमेटिकली जनरेट होता है. यू हैव टू राइट जस्ट लाइक व्हाट इज माय सम. दिस इज द वे टू राइट द कोड. लाइक सम विल बी लाइक ए XOR B XOR C, and then terminate this statement. After that like carry this is the basic logical expression for your full adder. After that B and Cin, and then terminate this. So, you have written the code for your full adder. This is for sum, this is for carry. This is actually this modeling is called data flow modeling, and there is another modeling that is called behavioral modeling. There are few more keyword for that, like process statement and lot of things, concurrent statement and like your step by step, उसमें कई और keywords आएंगे. So, first we will take this data flow and then and behavioral. Similarly, in structural में क्या होगा, you have lot of component and you have to just connect the input and output port. You just declare the component like and what will be the behavior of the and that is already there in this software in library cell. So, you have to add that component and just connect the input port, output port. So, but for large design that is like impossible to just interconnect the like input output ports. So, better to start from behavioral type of modeling or like data flow type of modeling. But finally, we have to synthesize this into gate level netlist. So, this is my full adder. I will save this. After that, I will go for this model simulate. I will simulate that will be functional simulation. I will check out that whether it is working or not functionally. Before that, I want to add one another module, pace module. For that, just click the file, new source, implementation constraint file, and just name the entity name whatever. The name should be same. This is like there is one like facility given to the user, that is called pin locking capability. Here you will lock the pin, like I have even that chip will like I have selected this one, this device 208. There will be 208 pins, and from that 144 are general pin. You can use that pin for your purpose, and other one are like for internal package. So, from that 144 pin, according to your design, you have to select at which pin you want input, at which pin you want to go for output. So, just this next finish. It will create one UCF file, user constraint file, we call this one. So, just after creating this, just double click this, it will open the pace file. So, like coding is not so difficult. If you once have like in mind like what I want to design, and you have everything, you have you can easily write the code. It will take very less time. But after that, like simulation, like your all kind of verification, that will take much time. So, like I am opening this pace window, it will take a time. This is my pace window. Here I can lock the pin. According to our design, like we have in manual, we have for this input like this one. Then for this can be different, like according to your design, what you have select means आपने input के लिए कौन से pin assign कर रखे हैं, and for output के लिए, and here like P109. P stand for like pin number, then P you can note down the flow also.
The third one is input, carry is for input.
Okay. okay, actually I have selected these two pin are like configurable pin. You can assign that as an input or output in our design, and these are actually dedicated input. I will give one practical session for this also. Tomorrow we will dump this code into that chip FPGA, and we will practically verify that whether means functionality wise whether it is working or not, and we can verify other codes also. So, after this just save this one. This is your user constant file. This is needed, like this is the flow actually, like this file is just needed to download that one. So, this is I will ask for like view schematic symbol. There are lot of option here, and like after that I will go to this simulator. This is the simulator called model sim. इवन यहाँ पर भी आपकी वो मॉडलिंग हो सकती है जो बेसिक वहाँ आप कोड लिख रहे थे, दैट इज़ पॉसिबल हेयर. After that you have to load that thing in this model simulator. Actually there is like there is one option you can integrate that one, like this one preference. Here you can integrated tool, and like this one, see this, you can integrate model sim, your simplify, these are the simulators. You can interface that with Xilinx actually, and they have their own simulator after the 7.1 series, after actually 6.1, and I have integrated this one model sim. That is why I just open this model sim simulator. I will close this one. This is the window for model sim. After that I will go to this file, you can note down the step. After that view signal, it has already downloaded that file in model sim. Signal means it will show all the input output port. So, just select the signal, add it. You can select this force, means what you want as 1 or 0, just give the input 1 or 0, or you can select the clock also. Suppose A input, I will give the clock this one. Okay. After that I will select the B, edit clock, and like I will change the frequency. You can change the option. After that OK, and finally last one scene, edit, again same clock. I have given clock because so that we can check out all the like possibility, input possibility 2000. Okay. After assigning the input, I will go to view, then wave and signal in region. This window will open, and there is option for run, only this one. See this, I will maximize this one. So, now you can verify your functionality, like see this, at this point I am getting output sum as 0, carry as 1, since my input is 0 1 1. Here again verify, all are 0, then my sum will be 0, carry will be 0. I have taken this clock because उसमें क्या होता है आपको एक एक करके then again change करोगे. So in this way this is the functional simulation we call that. There is another timing simulation that is a little bit difficult actually. So this is the basic flow for your front end part. Just write the code. If you want to download that, then create this UCF file and just go for this. After that, after simulation, suppose you have verified that okay, my code is working functionality wise, you can go for the other next process, that is called synthesis. First of all, I want to see the RTL schematic of this. There is option that you can check out the RTL schematic. See this is the macro for your full adder, input A, B, C in carry and sum जो आपने लिया था. Double click this. See the internal logic. ये black box के अंदर you want one XOR. This is the optimized like you can say schematic based on this dialing. Click again. This is the internal one. And even there is another that is called technology schematic, that is based on LUT. You are familiar with LUT, lookup table. That is like उसमें आपने mention कर रखा है, you have mentioned that कि these are the अगर मेरा input ये है तो I should get this output. So based on that you can check out that technology schematic file also. Just click this one LUT. It required at least 2 LUT. Internal will be this one. ये तो अभी सॉफ्टवेयर ने ही जनरेट किया है, so nothing new. After that you have verified your functional part, you have verified the schematic like okay, schematic wise is okay, and area wise भी आप चेक कर सकते हो manually, और there is option for like using the software also. Now I will tell the flow what we need to dump that code. Suppose ये आपने बना लिया है, this is actually non real part. आप exactly नहीं कह सकते कि ये this is a simple example actually, लेकिन अगर बड़ा module है तो you can't say exactly that practically it will work or not. So FPGA and CPLD technologies, that's why they become too popular, because that will be in between your back end and front end. Like you have written the code, after that you have verified the functionality wise, and after that you just click this synthesis, right click, you have to just click that, it will give the report, synthesized report, and it will automatically convert this gate level module into like your no, this is data flow modeling actually, data flow modeling into gate level. It will take some time. Even you can write down the flow also, what will be the flow for that dumping the code. First one is like writing the like design entry, first one you will enter the code, after that create UCF file, then after third one functionality wise no need to check that one, that is like for your satisfaction, but after creating the UCF file just generate this synthesized report. Now it has generated, see this according to the technology, like so I have selected this technology, according to the internal architecture of this technology my file will be generated, synthesized report. Let us see what is there. See this, it have given me information that out of these much of slices I have utilized only single one, and out of these much of LUT I have utilized only 2 and from this number of IOs I have utilized only 5 pins. So definitely for small design there will be wastage of money, like आप एक FPGA में that's why I am saying that why we prefer ASIC. क्योंकि FPGA जस्ट यू आर वेस्टिंग दैट एरिया एंड लाइक इतना मेमोरी वेस्ट हो रहा है इसमें। अगर आप मान लो FPGA फुल एडर ही बनाना चाह रहे हो, यू वांट टू डंप दैट कोड एंड यू वांट टू यूज दैट FPGA एज अ फुल एडर, so that will be the wastage of area and even that will be not efficient, so much efficient, the performance will be very low. So after synthesize, next step will be, you can write down that one, implement. In implement there will be three process like translate, map and place and route. These will be generate automatically actually according to the internal algorithm, those are optimized actually. Translate, it will convert that gate level whatever module is we obtain from synthesis into like Boolean expression, optimized Boolean expression, unoptimized. Here right now it is unoptimized. After that another process is mapping, that Boolean expression, that internal expression will be converted into optimized and like according to the architecture of this one. So, that process is called map. Translate means that is converted into that internal gate level module into some Boolean, unoptimized Boolean expression. After that according to some algorithm it will be mapped. Mapped means according to the technology architecture, internal architecture, it will convert that into optimized internal codes. And after that it will go for proper place and route, because up to now we have not gone through for this place and route. We have just optimized, we have concentrated only on the blocks like all the like जो भी उसमें आपके basic gates use हो रहे थे. So, proper place and route will be done automatically. You just need to just right click and rerun all, and it will generate the report also. Translating का भी mapping का and for place and route for all of us. So, this is the third step. First one is like design entry, second one is like synthesis. Of course, the UCF file you have to generate UCF file, the synthesis, and then implementation design. %66 is completed, and there will be lot of internal file will generate along with this process. You can check out that also. Okay, next step will be like after this this one translate will go for generate programming file just next to place and route. This will generate one like .bit file, that is the extension actually, .bit file for your FPGA and .jd file for CPLD technology. So, after clicking this generate programming file, it will generate the file, and after that you need to go to this last one, that is configure device impact. So, before clicking this, just connect the board, whatever board you have, that board will be like I will show you in brochure. We will have one practical session tomorrow for this. This is the board, and see this is the FPGA chip Spartan 2, Spartan 3, whatever. I have selected this one Spartan 2, 208 pin, and then these red one are like dedicated, these are inputs, and these are configurable IOs. You can configure that as input or output. you can configure that, but these are like dedicated. These are the dip pin, there are some jumpers, you have to set that jumper, and like system reset, there is system reset, this is the JTAG port for downloading, and like there will be even low frequency clock, and this will be the multiplex for 7 segment display, and there are lot of things here. You can there is 144, I have already discussed that there will be 144 channel pin. We have designed these boards in such a way that we can utilize all the pins. We have utilized that for this one. After that, your ADC DAC, rolling matrix, and like microcontroller, and you can interface that. Here is the flexibility we have provided, these pins. You can use these pin for your own application also. So, after connecting this board with this PC, I will just go to this impact, last one, impact, and after that there is option. We will see that thing in practical. Actually, there will be option, I have to just click on that. After that, it will be downloaded into this chip. So, this provider like this will take few seconds. After downloading, you can verify. Suppose I have given in paste window UCF5, I have given these 3 as input port and these 2 as output port. So, I will practically verify using these dip pins, like all are 1, then what will be my output, like 2 are 1, what will be my output. In this way, functionality wise you can verify. So, that is why this technology is like popular. We are not going for bulk development like bulk production, but we can verify that it is okay. Now, we have written the code is perfect, and now we can switch to the back end part. This is all over all about the front end part, and if someone want more than that, we will discuss on later part. Thank you.